As discussed earlier, the dry runway fuel length limited weight performance is based on the longer of the all-engine accelerate go distance to 35 feet plus 15%, or the engine inoperative accelerate go distance to 35 feet, or the accelerate stop distance, assuming a maximum effort stop on a dry runway with no credit for reverse thrust. If the runway is wet, not dry, and the dry runway performance weight and V1 speed is used, the following would be the result. The all-engine distance to 35 feet would not change because a wet runway does not affect the airplane's acceleration. The engine inoperative accelerate go distance to 35 feet would not change for the same reason. But the accelerate stop distance would increase because the stopping capability is degraded due to the reduction in tire-to-ground friction on a wet runway. As we can see on the graphic, if the airplane flight manual dry runway limited weight and V1 speed are used on a wet runway, the airplane may not have the ability to stop on the runway. In the airplane flight manual calculations for wet runway, we are allowed to use different assumptions in computing the performance. The wet runway engine inoperative accelerate go distance is computed based on a reduced screen height of 15 feet. As mentioned before, the accelerate stop distance required is increased due to the reduction of tire-to-ground friction on a wet runway surface. But the airplane flight manual wet runway stopping performance takes credit for reverse thrust on one engine. Taking credit for 15-foot screen height and one engine reverse thrust reduces the effect that the wet runway has on the fuel length required. To further reduce the effect of wet runway takeoff performance, the calculation rebalances go and stop to obtain a new lower wet runway V1 speed. The combination of a wet runway, 15 feet screen height, credit for one engine reverse thrust, and the rebalancing to a wet runway V1 speed still results in a takeoff distance longer than the airplane flight manual dry runway calculation. Therefore, the allowable field length limited takeoff weight on a wet runway will be less than the normal field length limited weight on a dry runway. Separate takeoff performance charts are provided in the Operations Manual and the Flight Planning and Performance Manual to calculate the wet runway fuel length limited weight and the wet runway V1 speeds. The wet runway fuel length limit weight will typically be lower than the dry runway fuel length limit weight. The wet runway balanced V1 speed will typically be lower than dry runway balanced V1 speed by 5 to 12 knots at the same weight, altitude, and temperature. Because V1 speed is reduced for the wet runway performance, the chance of V1 speed being limited by V1 MCG is increased. Even when the runway is wet, the airplane would be limited by minimum field length only on a very short runway. The charts in the Operations Manual and the Flight Planning and Performance Manual are used in the same way as the charts for dry runway takeoff calculations. As mentioned earlier, unlike older models, the airplane flight manual now contains fuel length limited takeoff performance based on a wet skid resistant runway. A wet skid resistant runway is commonly known as a wet grooved or a porous friction coarse runway. The airplane flight manual allows use of the wet skid resistant performance on runways constructed and maintained to meet FAA advisory guidelines. Separate takeoff performance charts are provided in the operations manual and the flight planning and performance manual to calculate the wet skid resistant field length limited weight and the wet skid resistant V1 speeds. The wet skid resistant runway field length limit weight is typically lower than the dry runway field length limit weight by less than 1,000 kilograms. In fact, in many cases, there will not be any weight reduction due to this wet skid resistant performance. This is particularly true at low altitudes and normal temperatures. The wet skid resistant balanced V1 speed will typically be less than dry runway balanced V1 speed by 4 to 8 knots. Because V1 speed is reduced with the wet skid resistant runway performance, the chance of V1 speed being limited by V1 MCG is increased. Even when the runway is a wet skid resistant runway, the airplane would be limited by minimum field length only on a very, very short runway. The charts in the operations manual and the flight planning and performance manual are used in the same way as the charts for dry runway takeoff calculations. As stated earlier, both the wet runway and wet skid resistant takeoff performance are part of the airplane flight manual. Because both the wet runway and wet skid resistant takeoff performance are based on a 15 feet screen height, the use of Clearway in the analysis of wet runway and wet skid resistant takeoff performance is prohibited. The obstacle clearance margin in the airplane flight manual results in the net flight path clearing the obstacle by a minimum of 15 feet. V1 improved climb is allowed with wet or wet skid resistant performance. Both the assumed temperature and derate method of reducing takeoff thrust may be used with wet and wet skid resistant performance.